Okay, so part A, which focuses on scale 1 from unit 1 and 2, says to translate the following equation 5 units right, 5 units up, and flip it over the x-axis. So part A, we have the equation of f of x equals 1 over x, which is the parent function for a reciprocal function, which the formula is a over x minus h plus k. So when we plug in the values, we get f of x is equivalent to negative 1 over x minus 5 plus 5. The values come from, so when we flip the equation, the parent function over the x-axis, the 1 becomes a negative 1, which is our a value. And then we divide that, and then the 5, which is our h value, comes from moving the equation 5 units right. 5, that is the k value, comes from moving it 5 units up. So now let's look at part B, which is g of x. So it says g of x equals x squared, which is the parent function for a quadratic. Formula for a quadratic is a times x, the value of x minus h squared plus k. And when we substitute the values in, which a, h, and k are going to be the same since it's the same shifts, we get g of x equivalent to negative 1 times the value of x minus 5 squared plus 5. Okay, moving on to part B. Part B focuses on scale 2 from units 1 and 2, and says, without using a calculator, graph the functions f of x and g of x, and comment on the important features. Compare and contrast the domain and range of the two graphs. So essentially this question has 3 parts. So let's start with the first part of graphing without a calculator. So to start, you would create a table. And for f of x, the table would look like this. So when we have x equivalent to 3, f of x equals 5.5. When x equals 4, f of x equals 6. When x equals 5, f of x is undefined because you'd have negative 1 over 0 because 5 minus 5 is 0, and any number divided by 0 is undefined. When you plug in 6 for x, you get 4, and when you plug in 7, you get 4.5. So when we graph this, you would get a graph that looks like this, and you have your 2 branches of the hyperbola, which have been flipped because normally they would be here and here, but because we have negative 1, we flip them. And then we have they're moved over 5 and up 5 because this indicates a shift to the right and a shift up. So it says to comment on the important features of the graph. So we have our vertical asymptote, which is this line right here. We have our horizontal asymptote, which is this line right here. And it then tells us to compare the domain and range between the two. So for this one, the domain and range of the function is equal to each other. We have negative infinity 5 union 5 infinity for the domain, and range is negative infinity 5 union 5 infinity. And that's just because our asymptotes happen to be at x equals 5 and y equals 5. So on to B, or g of x. So we do the same thing. We'd create our table. So when you input 3 for x, you get 1 for g of x. X equals 4, g of x equals 4, x equals 5, g of x equals 5, x equals 6, g of x equals 4, x equals 7, g of x equals 1. So we can use that to create our graph. So we get our parabola, and we have our vertex here at 5, 5. And since it says to comment on the important features, we are going to label our vertex. It also says to compare the domain and range. So with this one, we have a domain of negative infinity, positive infinity, or all real numbers, and a range of negative infinity up to 5, up to and including 5, because you cannot have a point exceeding a y value of 5, because that's the maximum point of this graph. So when we compare the two graphs, obviously they look very different because this is a parabola, this is a hyperbola, and they have different domains and ranges because this cannot have anything this will have no value at x or y equals 5, but this will not have anything that exceeds 5. Okay, so part C, which focuses on skill 8 from unit 3, says to find the limit of the functions that you found in part A as x approaches 5. In other words, we're going to be finding the limit of f of x as x approaches 5 and the limit of g of x as x approaches 5. So we're going to start with the limit of -1 over x minus 5 plus 5 as x approaches 5, which is f of x. So to do this, we create two charts, or two tables. We have one with values of 4.9, 4.99, and 4.999, and 6.01, 6.001, and 6.0001. And as you can see, these are not approaching the same values, and these are actually getting infinitely larger. So we would say that the limit of -1 over x minus 5 plus 5 as x approaches 5, or the limit of f of x as it approaches 5, is equivalent, would have no limit. So now let's move on to part 2 with g of x. So we have -1 times the value of x minus 5 squared plus 5 as x approaches 5. So we would do the same thing. We would create the tables, and as you can see, these are both approaching 5. So as x is approaching 5 from the left and x is approaching 5 on the right, g of x is also approaching 5. So we would say the limit for this function is 5. Okay, so on to part D. So part D focuses on skill 19 from unit 4, and it says to find the maximum y value of g of x using tangent lines. So we have g of x, and we're going to simplify this. So we have our equation for g of x, and then we I started by simplifying the x minus 5 squared to get x squared minus 10x plus 25 times 1 plus 5. So when you simplify that further, you get x squared plus 10x minus 20. And we are going to plug this into the equation for the limit of g of x minus g of a over x minus a as x is approaching a, because this will give us our equation for the tangent line to find the maximum y value. Okay, so we're going to take this and substitute in our new equation. So we get this, which is negative x squared, the limit of negative x squared plus 10x minus 20 minus the value of negative a squared plus 10a minus 20 over x minus a, which when we distribute out the -1, we have negative x squared plus 10x minus 20 plus a squared minus 10a plus 20, and the minus 20 and plus 20 will cancel out with each other, and all of this is over a. So I rearranged the equations so terms with like powers were together. So we have negative x squared plus a squared plus 10x minus 10a all over x minus a, and we are finding the limit as x approaches to a. So we are now going to factor this, and we get -1 times the value of x plus a times x minus a plus 10 times the value of x minus a divided by x minus a. So we are looking for the limit as x approaches a. And we can simplify that to get -1 times x plus a plus 10, that value times x minus a. And all of this is over x minus a, so the two x minus a's cancel out. So now we are left with -1 times x plus a plus 10, which when we distribute out a -1, we get negative x minus a plus 10. And at this point, we have simplified this as far as we can. So we are now going to replace x with a, and we will get rid of the limit. We will stop writing the limit of x as it approaches a, because we are down to where we would get our equation for our tangent line. So we're going to come over here, and we now have negative a minus a plus 10 because we had negative x minus a plus 10. We're substituting a in for x. So when we simplify that, we get negative 2a plus 10, which that is our slope of the tangent line. So we're going to take the negative 2a plus 10 and set it equal to 0 because the slope of the line tangent to the maximum point on our graph is going to be 0. And we are going to solve for a. So 0 is the slope to find the maximum point. And to solve for a, you subtract 10 from both sides, so you have negative 2a equals negative 10. Divide by negative 2 on each side, and you are left with a equals 5. So that is your x. So that is the equation for your tangent line. So when we look at the graph, we would have a line running straight across at y equals 5 and would intersect only at the point 5, 5, which is the maximum point of the graph.